Hello everyone and welcome. I'm Jonathan Hill, and in today's webinar, Daniel Kaminsky will highlight a number of exciting new features in NX and Simcenter 3D12. These products have already been released, so you're free to go ahead and download them from the GTAC site today if you haven't done so already. And before I turn it over to Daniel, I'd like to give a quick overview of ATA. So most of you are probably familiar with ATA either through our role as a Siemens partner and reseller or through our robust engineering services. And really these two go hand in hand. We have experience providing engineering services across a wide range of industries, and since we're solving the same issues as our software customers every day, it really helps us provide exemplary support and put the value added in value-added reseller. So on the services side, our focus is on analysis and test-driven design. ATA is proud to help our customers meet their toughest engineering challenges, whether that involves ground vibration tests on state-of-the-art aircraft, helping to ensure the safety of amusement park attractions, or analyzing the next generation of spacecraft and planetary rovers. Of course, being experts with Siemens PLM software helps us do just that. Speaking of the software, here are the different Siemens product lines that we use every day and can help you with. We host a technical support hotline service from 8 a.m. to 8 p.m. Eastern Time, which is staffed by experienced engineers who use these tools every day. And you can contact these subject matter experts by phone or through our website. We also can assist with license sales, and we offer training to help your team use these tools to their fullest capacity. The classes range from introductions to FEMAP and FEA to more advanced topics, things like dynamic response, super elements, optimization, and more. The full schedule of upcoming classes is available on our website, and in particular, I'd just like to mention that ATA develops and is the preferred North American training provider of NX MassChain. So I've mentioned our website a few times now, and here it is, ata-plmsoftware.com. As we've discussed, it houses the full list of upcoming classes, and existing users will find a link to our support hotline. In addition, it has software product information and links to download free trials, but best of all, it offers a growing collection of free resources aimed at our customers' needs. These are things like white papers, training videos, tutorials, APIs. There's just a ton out there, and I'd like to invite you to check out these free resources after the webinar. But until then, I'd like to hand things off to Daniel for the main event. So Daniel, take it away.
Hello everyone. As mentioned, my name is Daniel Kaminsky, and I will be guiding you through the rest of this webinar to explain some of the exciting new features we are going to be seeing in NX and SimCenter 12. So let's begin with a very brief overview of the SimCenter portfolio, and then we'll talk more specifically about SimCenter 3D. The SimCenter portfolio consists of solutions that span controlled simulation, 3D simulation, and testing solutions. The portfolio covers a number of physics disciplines as represented by the inner circle in the wheel on the bottom left-hand side of your screen. These solutions are further enhanced with multidiscipline design exploration capabilities. The solutions are available with integrations to Teamcenter to enable data and process management and complete traceability. SimCenter 3D features fast and accurate solvers, including structural, acoustics, flow, thermal, motion, and composite analyses, as well as optimization and multi-physics simulation. With this new release, Siemens has mainly been focusing on supporting generative design and additive manufacturing workflows, improving the efficiency of the CAE model build process, new workflows to improve the usability of post-processing, and general enhancements across various areas of the product. So I've broken down the enhancements in NX and SimCenter 12 into 4 categories. Modeling, where we will focus on new tools and additions to existing functionality to increase productivity and design complex structures more easily. I will also focus on some of the improvements made for creating complex assemblies. Changes to the user interface, including the ability to have multiple display parts and selecting parts using a new 3D box selection tool. Improvements to the pre/post program, including new extremely useful selection recipes and general meshing enhancements. And finally, I will touch on some of the new nonlinear solution capabilities. You will notice that a lot of the significant additions to the software have been made in the pre/post category. So as many of you probably know, convergent modeling was first introduced in NX 11. For anyone that is unfamiliar, convergent modeling is a new and exciting concept that is probably one of the most significant enhancements to the suite of NX and Simcenter tools in recent years. Essentially, what convergent modeling allows you to do is work with solid surfaces and facet bodies without having to do any data conversion. With the growth of laser scanning, additive manufacturing, and topology optimization, working with facet bodies is becoming essential in the engineering field. So you can now import your scan data to NX as conversion data. You will then be able to immediately perform geometry modifications to this convergent body. So you can skip the time-consuming process of manually matching boundary representation and analytic geometry to facet geometry, which was required in the traditional CAD reverse engineering workflow. So as I just mentioned, you can directly import STL files as NX convergent bodies, or you can convert facet geometry to a convergent body using the convert facet body command. You can also use the new convergent body from body command to convert an existing polygon body to a CAD convergent body and store that new body in a part file. This capability is helpful when you want to make geometry modifications to a polygon body that is not associated to any underlying CAD geometry. And it should be pointed out that this command is only available in the pre/post application. So once you have a convergent body, you can start using a variety of powerful modeling tools to help you easily manipulate and take control of your geometry. You can use the cleanup facet body command to check facet bodies for imperfections and repair them. You can use the merge facet faces command to combine two or more adjacent facet faces. You can use the divide facet face command to do the opposite, so you can divide your facet faces to create a more useful topology. Finally, you can use the create transition command to create a round rolling ball type blend or a flat symmetric chamfer along the edge of a facet body. So using convergent geometry definitely significantly reduces development time and potential manual errors. With NX and Simcenter 12 also comes some useful changes to the Face from Mesh tool. The Face from Mesh command is a powerful tool that allows you to convert 2D elements or 3D element faces into sheet bodies. This is a very useful tool if you want to easily remesh a 2D FEA model, but you no longer have the associated geometry. This tool has been available in previous versions of NX and Simcenter, but many enhancements have been made. They now have a 2D mesh option in the Face from Mesh tool. So previously, you would have to execute the Face from Mesh command multiple times to separate each mesh region into different faces, but now you can accomplish this all at once, saving a lot of time for complex models. The Face from Mesh command will now also automatically create polygon bodies from non-manifold meshes and automatically stitch the non-manifold intersections. So also saving you the extra step of, after you execute the Face from Mesh command, having to go in and stitch edges. The Face from Mesh command is another useful application for convergent modeling. If you want to make geometry modifications to the polygon body you created from the Face from Mesh command, you can convert the polygon body to a convergent body using, as I mentioned earlier, that convergent body from body command. This command will then allow you to store this new body in a part file and associate the polygon body to the convergent body. So that way, if you make any changes to the convergent body in the CAD part file, the polygon body will update in pre/post. So here we have a really quick demo showing how to use some of the, use the new features available in the Face from Mesh command. So we have a simple 2D mesh with no associated geometry. You can see in our simulation navigator that there is no geometry present. So we'll go to our polygon geometry section, click on More, and select Face from Mesh. You will notice in the Face from Mesh dialog box there are 3 different options available. We're going to select the new 2D mesh type. We will then click on our 3 different meshes in this model, and we're going to accept our default angle values here. We'll click on Preview Edges to see what kind of edges the polygon, or the Face from Mesh command is going to create for our polygon body. You can see we have some edges here, but we're probably going to want more edges in our polygon body for it to be more useful. So what we can do is we can easily start playing with these different angle parameters here. So what I'm going to do is I'm going to decrease the element face feature angle parameter. Decreasing this parameter will create more polygon edges. What this parameter is essentially the angle between adjacent 2D element normals. So the command will create edges when the angle between normals is greater than the specified parameter. So I'll give this a random angle of 20 degrees. I'll click on Preview Edges again. And you can see we have significantly more edges that the Face from Mesh command is going to create for our polygon body. Even some edges we probably don't want, but we'll go ahead and accept. So now we can hide our 2D mesh and we can see the new sheet body that was created using the Face from Mesh command. You can also easily remove any unwanted polygon edges using the merge face command, which has existed in NX and Simcenter for quite a long time. So we can easily delete most of these unwanted polygon edges. You can even obviously keep in some useful polygon edges if you think it's going to help the mesher be able to more appropriately mesh your polygon body. So after we've deleted all the unwanted edges, we can select OK on the Merge Face dialog box, and then we can update our mesh. So you can see we now have a 2D mesh that is fully associated to a polygon body that was created using the Face from Mesh command. Siemens has also implemented many tools targeted at the growing rise in 3D printing or additive manufacturing. One such tool is the Lattice tool. This command allows the user to easily fill internal volumes or surfaces with complex lattice structures. You can specify the cell type, orientation, and size of the lattice with ease. The unigraph lattice type can be used to quickly replace a body with a lattice structure, while the conformal graph type can be used to create a lattice structure that follows the contour of the face. So you can see an example of the lattice dialog box here, and you have a bunch of different options for your cell types. And NX and Simcenter will even give you an small representation box showing what these different cell types look like. So now we have another quick demo that will show you how to use the Lattice tool. So here we have a simple bracket that has been split into two separate bodies. And we're going to use the smaller internal body to create the lattice structure. So we will easily locate the lattice structure in your menu here. Now, as I mentioned, we'll use the unigraph type to replace this body with a lattice structure. So all you have to do is select the body, and immediately you'll get a representation of what your lattice structure will look like. So you can quickly specify the edge length, rod diameter, and orientation of the cell. For cell type, we're just going to use the default bi-triangle. We'll go ahead and accept this result. We'll then hide our original solid body, and you can see we have replaced, or we have created in that same solid body region, a useful lattice structure. There have also been some updates to the variable offset face command. You can now create offset regions of different thicknesses. You can also use the new pad type picture on this slide to create parts that contain different materials. There is also now the option to offset as a solid if you select the output for the variable offset face tool to be a new body. So what that means is if you look at this variable offset face dialog box example, if under your body output you have that selected as offset as new body, you also have this box you can check here to offset as solid. So here we have another quick demo demonstrating how to use the variable offset face pad type. So we're going to use the sketch in the middle of our part here to create our variable offset face. So to access this command, I'm going to actually use the command finder in this case, just because it is a quick and easy way to be able to get to a lot of your commands. So if I highlight it here, you can see the, if you want to use the menu options to access this command, this is how you would do it. You would go to Surface, and then under Surface Operations, More, and then Variable Offset Face. We'll click on the commands. As I mentioned, we're going to use the new pad type. For face, we'll select the face that the sketch relies on. It automatically selected body faces, so I'll change that to single face. For region boundary, I'll select that sketch. And you can see the variable offset face command has automatically broken up that face into 3 separate regions. So we'll go ahead and give each of these regions a different offset. Just random offset values. And you can see we are creating a stacked sort of setup here from the variable offset from face command. What you can also do is I'll click on region 2 and I can change it from offset to bridge to create this pad type of offset face. And under body output, as I mentioned earlier, I have offset as new body, so I can check mark the offset as solid option. And now it has created a solid body from the variable offset face command. So I'll hit OK. I'll change my selection filter to solid body just to confirm. You can see that in fact we do have a solid body created from that command. A number of improvements have also been made to how you interact and manipulate assemblies in NX and Simcenter. There are a variety of new options available to add components to assemblies. Most significant is the addition of the custom anchor points. In previous versions of NX, when you had a component, you could only select its absolute origin as anchor point. Now you can identify other points as selectable anchor points, giving you greater flexibility to add components in their correct orientation and speed up your process of component placement. Furthermore, the move and constrain options have also been directly integrated into the Add Component dialog box, creating a single interface for adding components. So in previous iterations of NX, you would have the move and constrain dialog box separate from the Add Component dialog box, but those have been merged to save you that extra step. Also, NX can now smart snap components to their correct orientation based on the assembly context. Finally, Siemens has made a lot of improvements to load large assemblies much faster while reducing memory usage. So there's also an exciting, really simple new feature, but it's actually one of the features I am very excited about in NX12, and that is this multiple display parts. So NX now lets you have multiple display parts in separate windows. This means that you will be able to switch between display parts significantly faster. You can also have display parts in split screen, like the example above. An example of one way this feature could really be utilized is if you have an assembly open and a part in that assembly in split screen. You can then modify the part and immediately see how it will affect the assembly. So that's definitely something that can come in handy when you're working with complex assemblies. So we'll show you another quick demo of how to use multiple display parts utilizing the split screen feature. So you can see on this example we have 2 different parts. So this is how the layout will look. We can easily click on this tab title to bounce in between our different display parts. Now to activate or to utilize the split screen feature, all we have to do is drag one of those tab titles, and then you can see we have 4 different split screen orientation options. We're going to select the right side, and you can see we now have a split screen between these 2 parts, and I can easily manipulate, rotate the 2 parts. One thing that is important to note is if you look over at the Assembly Navigator, you will see the Assembly Navigator is reflecting whatever is the active display part. So what this means, you can see that this Model 1 part is highlighted in this blue color here. That means it is the active display part, and the Assembly Navigator reflects that. You can easily change whatever is the active display part by either clicking on the tab, which I just did here, or clicking anywhere in the screen selection for that part. So it's just an important thing to note when you are working in split screen that your Assembly Navigator will reflect whatever part is the active display part. There have also been many new gestures that can increase your efficiency and make it easier to navigate the NX environment. You can now double click in the background to fit your part to view. This is definitely something I'm going to utilize just to increase my efficiency just a little bit more while using the program. You can still use Control F or click the Fit button to fit to view, but definitely double clicking in the background will be the quickest way to execute fit to view. You can now also single click in the background to deselect any object. Obviously, you can still use the escape command to deselect, but just another useful addition they've made to hopefully increase your efficiency. There's also a new tool that allows you to select components using a 3D box. So this is very useful for complex assemblies. You can specify the selection as what is inside, outside, or crossing the box. So you can see we have an example of the 3D box selection tool here. This is where you would find it in your NX menu. And under box select rule, that's where you can specify inside, outside, or crossing. So just another really quick demo demonstrating how to use the 3D selection box. So as I mentioned on the previous slide, we will find the 3D selection box command right here. So we'll click on that. You can then select any polygon feature to define the initial box size. So I'm going to just select a random polygon body. Then for box selection, you can easily manipulate the box volume and hold these different faces. You can then move the box if you wanted to. For now, just for this quick demo, I'm just going to accept the inside the box rule. And you can see that this component was the only component selected from that 3D box selection command. If I had used crossing, all of the components that intersected the 3D box would have also been selected. There have also been some improvements to the undo list. So you can now undo all of your commands from the undo list. In previous versions of NX, you could only undo 8 commands. NX's undo list will now also show you which part the command was executed in. So you can see an example on this slide. We have these different commands that were executed in different parts, or for different parts. So you can see that it shows for this clamp 2 part, we did these delete face commands, while for this trailer hitch part, we did a full pull face command. Furthermore, NX now highlights the commands in the undo list to mark the command that will be reverted. So when you click a particular operation in the undo list, NX reverts all of the highlighted operations, regardless of whether or not the reverted operations belong to the same parts. So in this example, see how these are all highlighted blue here? So when this is selected for the undo list, all of these commands will be undone, even though they were executed in different parts. NX will reset the undo list if you change the displayed part to one that is not already displayed in a window, or the from and to applications do not support retaining the undo list. So in this example, if you were to change to the pre/post application and then come back into the modeling application, as always with NX, you will have lost your undo list will have been reset. Topology optimization is another feature that was focused on with the release of SimCenter 12, but some useful changes have been made with this release. For those of you who don't know, topology optimization is the process of using a FEA solution to optimize material layout based on a variety of factors, including boundary conditions, loads, and manufacturing constraints. Essentially, topology optimization is used to reduce weight and design complexity while maintaining the structural characteristics of the original design. You can use topology optimization for assemblies or individual components. It is important to note that the output from topology optimization is generally faceted data, hence another use for convergent modeling techniques. The improvement or the change to topology optimization, the topology optimization process includes the new SOL 200 topology optimization solution with the NX Nastran solver. So you can see an example of what this new SOL 200 topology optimization looks like in your pre/post sim application. So you will be able to optimize the topology of your part or assembly based on a number of factors, including a design objective, such as minimizing your weights, design constraints, including bounding your frequency or weight, and manufacturing constraints, for example, if your model must be symmetrical. The documentation for SOL 200 is vast. In fact, you could probably give a whole webinar on this subject alone. So I highly recommend exploring the Siemens documentation for this if any of these capabilities for topology optimization sound useful to you. Selection recipes are a new SimCenter feature that I am personally very excited about. Selection recipes let you select FE or geometric elements based on a set of rules. So some of the things you can do with selection recipes, for example, is show or hide elements in a selection recipe, or use the selection recipe to apply loads or constraints to the elements in that selection recipe. Different selection recipe types include attribute, bounding volume, single label, label range, coordinate, or points. You can see an example of the create selection recipe dialog box here and those different types that you can select. So here we're going to do another quick demo just showing you one of the many ways you can use selection recipes. So we will be using a selection recipe attribute type to apply loads to a polygon face. So in this example, we have a part that has a few different square faces. We'll first create the selection recipe. So you go to your simulation navigator, you find selection recipes, you right-click, and select a new selection recipe. So as I mentioned, we have all these different selection recipe types. We're going to use attribute. We'll rename the selection recipe as Foce_recipe. We'll change our entity type. We have a bunch of different options, but we'll select polygon face. For attribute, we also have a few different options. As you can see, name, color, and user attribute. We are going to use name. We'll hit add attribute, which is that button there. Then for our name, we'll change this to Force. So what the selection recipe is essentially going to do is every polygon face that is named Force is going to be automatically added to the selection recipe. So if we hit show result, you can see nothing is selected because there are no polygon faces that meet this requirement. So now we'll go to our selection filter. We'll change it to polygon face. We'll right-click on one of the polygon faces and select properties. We'll go to general, our general tab, and for name, we'll type in Force. We'll now go to our Force recipe. We'll right-click and select contents. You can see that now this polygon face has been selected. We'll now add a load applied to the selection recipe. So we'll do new load, Force. We'll change our selection filter to selection recipe. We'll click on our Force recipe that we created, and we'll give it a random 10 Newton normal force. You can see the load has been directly applied to that selection recipe. So now I'll show how you can easily add more components to the selection recipe. So I'll click on the other three polygon faces. Once again, I'll right-click and select properties. And once again, I'll easily rename all of these polygon faces to Force. Now you can see the load has automatically updated because that load is being applied to the selection recipe, and all four of these faces now meet the selection recipe rule requirements. With this release also comes a new lightweight SimCenter 12 results viewer application. This application will allow you to view results without opening the entire SimCenter interface. You can just open the results viewer application and quickly review your results there. So this will allow you to share results without needing a SimCenter pre/post or motion license. Another new feature is the edit post view dialog box, which you can see on this slide. In previous iterations, the set result dialog box used to specify which results to be displayed or to specify nodal averaging was separate from this post view selection menu. However, these are all in one dialog box now to once again help you streamline the process of the post-processing procedure. So this results tab here, all these options used to be a separate dialog box, but as I just mentioned, they have all been merged into one. So definitely something that can be very useful, again, for increasing your efficiency. It can be definitely tedious when you're working on a big post-processing task to jump in between multiple dialog boxes. There have been two main enhancements to the mesh point constructor. First, you can create a mesh point in the interior of a volume. So that is this inside solid type option that you see in this mesh point constructor dialog box. So this can give you more control over how your component will be meshed, and it's definitely something that can be useful if you're meshing fluids. If you want to have a specific node location in the interior of your fluid, you can use it. You can specify it using this inside solid mesh point type. The second addition to the mesh point dialog box is this assign node label option. So now you can click this and you can assign the node ID for the node that will be created at that mesh point. So this will save you the extra step of having to go in and manually modify the node ID after it is created using the mesh point. There have been some subtle but useful new additions to the 2D mesh dialog box. You can check the skew box to specify the maximum skew angle, which is right here. You can also select the new target maximum element length option to specify an optional maximum edge length value for the elements in the mesh. So that is right here. So if you check this target maximum element length box, you can now specify a maximum element length value. The target minimum element length selection controls whether the software attempts to ensure that the mesh does not contain any elements that have an edge length smaller than the specified small feature value specified by the small feature tolerance slider. So what that means is if you select this target minimum element length box here, it'll use this value specified using this small feature tolerance slider as your minimum element length. The surface curvature-based size variation slider, which is here, replaces the old curvature-based size variation slider. So essentially, they just added surface to the name here. But it's supposed to be a more powerful option that lets you vary the size of your elements in regions of higher surface curvature. So this will allow you to create more and smaller elements in areas of higher curvature. The internal mesh gradation slider, which is here, replaces the element growth rate through volume slider. The internal mesh gradation slider defines the value that the software uses for increasing the length of one internal element edge to the next internal element edge. So you'll also have the option to specify the internal edge length limits, and this selection is the boxed location on the 3D TET mesh dialog box here. So similar to the 2D mesh dialog box, you have this target internal edge length limit that you can check and then specify the value. So the internal mesh gradation slider gives you the ability to have a larger expansion for reduced mesh sizes, but the use of a cap means that the element size could be prevented from going too far. So constant gradation through the volume would be a value of 1, which you can see on the bottom left-hand side of your screen. We have a pretty even mesh through the volume here. While the picture on the bottom right of your screen is a gradation of 2, and you can see the progression of element lengths as you transition from the body surface. Another useful feature for brick meshing is that you can now sweep a mesh from multiple source faces to multiple target faces. So in the past, you could only sweep to a single target face. But it should be noted that the selected number of source faces must match the selected number of target faces. And as always with swept meshing, the source and target regions must have a similar topology. Another new swept meshing feature is the ability to use the manual between swept mesh type using source and target faces in the same body. So this can be used to fill gaps in a mesh, and so this is a very useful feature and will eliminate the need to do any extra modeling to get a swept mesh across the gap. So you can see an example of this feature on the bottom left side of your screen. I was easily able to mesh this gap in this 3D swept mesh here, even though there's no polygon geometry for that region. There have also been some useful additions to the mesh controls. You can now use the new point type of mesh control to specify the size of elements at a selected mesh point or vertex. So with this type of mesh control, you can specify the element size at the specified point and the radius of influence around the specified point in which you want to use that element size. You can also use the new bounding volume type to control the size of elements that are created within a bounding volume region selection recipe. So there's an example of this bounding volume mesh control, and you can see that a bounding volume selection recipe is required to use this mesh control. It should also be noted that this type of mesh control is only applicable for 3D TET meshes, not 2D meshes or brick meshes. So we have another quick demo where I'm going to show you how to use that bounding volume mesh control. So as I mentioned, as you can see on our screen, that we have a piece of an aircraft housing here, and we're going to assume we just want to apply a mesh control to this sort of hub interface location right here. So we'll create a new selection recipe. We have our bounding volume type that we're going to use. I'll go ahead and hide the 3D mesh to make it easier to see. And then you have a bunch of different methods for your bounding volume definition. I'm just going to use the default coordinate system and edge lengths option. So now I can click anywhere on this polygon body. And so you have a few different options of how you want to specify your volume box. Or you have a few different ways you can do this. You can either specify exact measurements that you made or just kind of play with the different edge lengths. On this example, I'm just messing with the edge lengths until I get the appropriate bounding volume that I want for this region. I then have to move that bounding volume to the correct location. That's what I'm doing here. So I wanted to just cover this whole component right there. So you can see now that I've now created a bounding volume. I'll move it a little in this vertical direction as well. But now I've created a bounding volume in the appropriate location. So for containment, you can also specify inside or inside/crossing. In this example, I'll do inside/crossing, and then for entity type, I'll do node or element. So what this means is that all of the nodes and elements that are either completely inside that bounding volume or crossing that bounding volume are going to be selected. So now I'll turn the 3D mesh back on so we can see, and then I'll click Show Result. And you can see all of these nodes and elements have been selected with this bounding volume selection recipe. So we'll select that, we'll accept that result. And now we'll go into our mesh control, and we'll use the new bounding volume mesh control type. We'll select the selection recipe. Then for our we'll select our polygon body for the polygon body. And then for element size, I'll increase the mesh density to 5 millimeters. So now you can update your mesh. This is a pretty dense mesh, so it can take quite a while to update. So I can actually skip forward in the demo here. So you can see once it is done updating, we're going to have a significant increase in the mesh density in the region defined by our bounding volume. You can see that is exactly what has happened. So this is definitely a useful feature for just having being able to control your mesh significantly, being able to take more control over your mesh, and it's definitely a feature I plan on using on future projects. So there have also been some general enhancements to the program, which I'll go through here. The main addition to the element qualities check, for example, is the ability to find elements whose surface area or volume is smaller than a particular threshold value. So this is useful for finding elements that are really small in your mesh. And another useful enhancement is to the section cut view. So now when you do a section cut of a part that has a 3D mesh, the cap along the section view now displays lines indicating the intersection between the plane and interior element faces. So all that to say, when you do a capped section cut view for a TET mesh, for example, you can now see the internal mesh edges, which is definitely a useful feature. Improvements to the Create Group tool have also been made, including the ability to assign group label IDs instead of having them be automatically assigned. It's another useful feature. There's a new display nodal coordinate system command that can be used to display the node reference or displacement coordinate systems for selected nodes or for the entire model. So that can be very useful if you want to quickly confirm that all of your nodes have the appropriate displacement or reference coordinate system. The node create command will now also allow you to define the nodal displacement coordinate system. This will save you the extra step of having to define the nodal displacement coordinate system after the node is already created. And finally, you can use the new element rotate command to easily rotate elements through an arc or about a point. So this command will make the process of rotating elements much more straightforward. So we'll also give a quick synopsis of some of the new nonlinear features in this new release. So shell, beam, and spring elements have been added to the SOL 401 nonlinear analysis. Also, you can now perform a post-buckling analysis in SOL 401. Siemens has also added the new SOL 402, which is multi-step nonlinear kinematics analysis, and this is ideal for complex systems with rigid body mechanisms. SOL 402 also supports large strains and large displacements, large rotations, and nonlinear materials, including hyperelastic. And it is based on the powerful LMS SamSep solver. So SimCenter 3D users can also directly access the power of the LMS SamSep solver via the SamSep environment. So this environment now includes different new capabilities related to composite materials like efficient management tools for global layouts. And it also provides dedicated scenarios for post-processing of damage and composites, which is definitely a strong point of the SamSep simulation environments. So that concludes the What is New in NX and SimCenter 3D12 presentation. I want to thank you all for attending. I really hope you enjoyed learning about some of the new and exciting features in NX and SimCenter. And I will open up the floor for any questions, but I do encourage anyone, if they have any questions at a later date, to please use the contact information on this slide. Thank you again.
Does anybody else use 12 here?
We can install it, right?
What's that?
We can't install it. Well, now.
I think so. Now you can, yeah.
I got it installed here. Awesome. It's just,
so if you do that install SimCenter, does that install the full NX stuff or just the SimCenter?
no, that will just install the SimCenter. So if you install NX, then
You should have the choice when you go to the GTAC site. It's two separate download programs, whether you download NX or SimCenter, although depending on your licenses, a lot of times they'll have similar capabilities between them.
So, Raj, when I first installed NX11, I couldn't find pre and post, and I think Robert told me.
Are there any other questions out there before we get off the line?
Yes, Daniel. This is Pete from Pazielli from BAE Systems. I'm here with Craig Paggi. We had a couple of questions about the Lattice capability, if you had a couple minutes, because that's something that seems to be rapidly being introduced into the industry, and the analysis has yet to catch up to it as far as what they can already build versus what we can really analyze. What type of elements is it actually using when it creates that lattice structure? Is it using like P-bar, P-beam type elements?
So it's actually just creating faceted bodies. So the application that I just showed was just on the modeling application side. Yes.
Oh, that's only on the modeling side, so it doesn't transfer over to the analysis side yet? It'll just keep it as a faceted body and have to be like solid modeled?
Correct.
Okay, so yeah, so it'll be solid. So then the way you could tie it together, I'm assuming you could create like a mesh mating condition and it uses either the glue coincident or one of the other methods to tie the two bodies together then.
Yeah, exactly. You should be able to use any of those mesh mating conditions to do that.
You could also probably just do like Boolean commands to just merge the bodies completely. Mm-hmm. I would imagine that would work.
Yeah, you should be able to do that as well.
Okay, and so Craig had a question about it's built the lattice, so the lattice will get merged into the power file. So it's just solid bodies, it sounds like. So okay, is there a separate license requirement for that feature?
Okay.
I'm not sure. I can check on that. I don't think so, but I can double check and get back to you.
Okay, and you did have a number of different lattice structures available. Is there a way to kind of create your own kind of single block lattice that could be part of that menu, almost like a user-defined?
I didn't see that option available. As far as I know, you can only just use those predefined different lattice types.
Okay. Anything else?
Nope.
Okay, I think we're good. Thank you. I appreciate your answering those questions for us.
Yeah, no problem.
Is there any other questions out there? Great, so I think that probably wraps it up. Big thanks to Daniel for his presentation today. That was really great. And I'd invite everyone to keep an eye on your email. I think we'll be sending out a survey later this afternoon that can let you know how we did and what we can improve on. And also, if you have requests for future webinars, we'd love to hear that, or any other resources on our website. Just feel free to let us know, and we'll see what we can do. Otherwise, thanks so much, and everyone have a great day.